about the size, because actually it seems that they are not so. The size is not balanced. So I can see that they are always the health and risk. Yes, it is balanced, but the data sets. You see, this one actually has like 500 records, right? This one seems to have like 300. This one like 160. This one like 140, and this one like one something. Okay, it's okay, but yeah, we need to also know that, because we need to also see if the size can affect the performance, right? So we need to have a way to quickly go see that, oh, actually, this one has this performance, but the size is this amount.
I can use the whole balance to split to 5.
If we need. Right now it's okay, but I'm just saying that we need to see for each data set what is the size.
Okay.
Later we can consider if actually we need them to be the same size, but normally no, because we are imagining that they are different data sets, right? So we can still treat them like if they were different size.
Okay.
But when I see an experiment like this, for example, well, not this one, sorry, like this, because this one is a little bit shocking, actually. I want to see if maybe there is a size relationship between here, right? If you compare this curve to all the other ones, you will find that it's a little bit weird. Don't you feel like normally this is a very nice curve, right? But this one, you see, it's kind of, the training is good because it's ascending, but in the validation it's a little bit weird.
I forgot to use the early start. Early start.
This chart we forget to use the early start, like
for the logs, right? Something like this.
Yes.
Because you see, this is more normal, right?
Yes.
There's a gradual increase until there is some point. And in this case, like the validation is always around some value, right? In this one, I also saw something a little bit weird. Like, for some reason, it crashes. So probably the training curve looks the same, right? But in validation, when we see, let's check the code. I'm expecting that one will have less, the accuracy will be less, right? So this one, this will have the result for all the groups, right? Are they in order?
Yes.
Right. So this is one.
in order to go right to go front.
Okay. I'm actually I think you can check the order of the output, because So I think this one is one result.
No.
But if you look at the validation accuracy here, it is not consistent with this value. This 8154
Oh.
looks better,
Stop.
looks more consistent with this one. Because if I see this too, for example, you see for group 1, the validation accuracy, looks more like somewhere around 86, right?
Yes.
So if I see these ones, if I had to guess, maybe it's this one or something like this. And the 81, maybe I would expect it around this one. So just check the order of the reports to make sure. And because here, also all of them say 21-23 split, right? So we cannot know for sure. We could look at the confusion matrix, I guess, but I think this output, maybe you need to confirm a few little things. So compared to the single, the last week experiment, where everything was together.
Yes, last week everything is together.
So how do you feel about this result? Is it worse, improve, or not
I
really?
think it's
A little bit worse.
Yeah, right. Oh, but here we only had SK.
Yes.
Right now we were looking. Everything was DM, right? Yeah. You see, so I guess this is expected because with more data, this one gets 90, right? But that is SK, so let me check. So may I know why do we have
one is adjust. Use adjust. One is not use adjust.
Oh, so you still keep it, buddy?
Yes,
Now it's in
yes.
the same file.
You can see it. So you can see the difference.
84, 87. Yeah, it seems sometimes one is better, sometimes the other
Yes,
one is better,
yes.
right? Not inconsistent.
I want to find a better
Parameter or something.
the better parameter to use.
So this one is using random forest, right?
Yes, I all use random forest. Next time I will try other algorithm too.
Yes, I think because there are many classification algorithms.
Yes.
Before I told you XGBoost. XGBoost is also using an idea about like trees.
Next time I will try.
But yeah, so you see that when we break up the data, the classification can suffer a little bit, right? Probably because the number of samples is not enough. So of course, if you have more, it's better.
Yes.
But I think it's still in a good range. So would you like to sum up the progress so far from before to now?
现在有照片。OK， 简单问一下，在有开会。
Okay. Well, can you summarize your progress so far?
比较能评价，
我这样讲，我们每周在干嘛而已。
可以，你讲一讲。You want to tell you how
What we do.
what we do in every week.
Okay.
So during the first week, and we focus on infrastructure setup and research direction planning, and we develop preliminary deep learning and prediction models and map out the project architecture using a mind map and establish a solid theoretical and structural foundation for subsequent research. So and the next week, in the second week, we officially introduced the scikit-learn machine learning framework to run in parallel with our deep learning model. This marked the beginning of our dual model comparative study, where we gather from more data and generating initial model outputs. And
Wow, so much.
yeah. Okay, yeah. And the focus of the third week shift to data quality. We establish a dedicated data and pre-processing model to clean missing value and transfer data. Meanwhile, we initiate parameter tuning experience on our machine learning model to explore their impact on performance. And during the fourth week, we concentrate on establish model evaluation metrics. And we introduce confusion metric for the first time to evaluate our machine learning model and experience with class weighting. A class weighting and data balancing technique to adjust data set in balance. So, this week is the fifth.
Last, you can say the last. So, can I know what you have in mind for the future direction?
To be honest, I don't think we haven't tried that much about the federal learning. We just keep it on the stage about the
Crazy model.
current model and whatever is the DN or skill learning
Yes.
is a good shot.
Yes.
We can make forward to about the federal learning.
So yeah, because my goal right now has been to ensure, like you were talking about, like we can have good data quality. and we can have stable baseline models. Okay, so we have to make sure that they are performing okay, and that these results that we are getting, that they are correct, right? Because if the model is actually have some problem or is not doing good prediction, then if we build something on top of that, trash builds trash. So we need to have a solid data and solid models. But yeah, even if now we begin to work with neural network or XGBoost or any other classification, yeah, now we can at the same time begin to look into the federated learning, right? Now, from what we have talked before, perhaps we won't necessarily implement like a full federated learning network. What we can do is a simulated federated learning architecture. But so that part you can also begin to search with your AI tools or online.
Okay.
Try to describe a problem, right? Like we have multiple data sets running on multiple models. We want to incorporate it in a simple federated learning simulation, something like this. Like how can we do it? I think this looks good enough. 17.